Okay, in this video we're going to go over number 2. This one's worth 10 marks. We're looking at this differential equation. It's a differential equation because there's a derivative. Notice the format it's in. It's in, dy dx equals p of x times y, and that's equal to q of x. And so this is in the form that we can then use the integrating factor method, right? And so the first thing we need to remember is, how do I find the integrating factor? The integrating factor is always equal to e to the integral of p of x, right? So let's figure out what that is. It's going to be equal to e, the integral of p of x. P of x is, let's just do integral p of x real quick. P of x is x over x squared plus 1. If you need to use chain rule, you can, or not chain rule, u substitution. Let's go ahead and do it. So you pick your u, right? That means we're going to do this. Then we're going to take the derivative so that we can solve for dx, right? So then instead of this dx, we're replacing it with du over 2x. You can see the x's will cancel. We'll be left with a factor of 1/2. The integral of 1 over u is natural log u, so we have 1/2 natural log u, technically plus c, but for the integrating factor you don't need the c, and then we take that u and we plug it back in like this, right? So our integrating factor is this, and I could also use a property of logarithms and bring this up, and it would become x plus 1 to the 1/2, which is the same thing as square root of x plus 1. Right, so this is the same thing as natural log square root x squared plus 1. And then we know that e and natural log cancel each other out. So my integrating factor is actually just square root of x squared plus 1. Right, that's my integrating factor. And that's what part A wanted, was show me that this is my integrating factor. That's my integrating factor. Right, so now it wants me to solve this differential equation. Which means I can go and multiply everything by this integrating factor, and then we should notice that something interesting happens. So what's interesting about the integrating factor is, if I find this integrating factor, then I know that the integrating factor times y, the derivative of the integrating factor times y will equal the integrating factor times q of x, right? And so we can actually check that here. So the derivative of integrating factor is square root x squared plus 1 times y, and then that's going to equal square root of x squared plus 1 times x. So what I want you to check is, like, if I actually take the derivative of this, then I should get this right here, and you can verify that this is true, right? The derivative of the first one looks derivative of the first one, times the second one, and then the second one times the derivative of the first one, and it would simplify out to be something like that. So we have this, and we're trying to integrate. So we're gonna integrate both sides of this. Your integral will cancel your derivative, and you'll be left with just the left-hand side as it is, square root of x squared plus 1 times y equals the integral of the square root of x squared plus 1 times x. And this, we can integrate this, not too difficult with, not too much trouble. It's going to be another u sub problem. So integrating the right-hand side, again, if it helps to use the u substitution, go ahead and do that. You could say u equals x squared plus 1, and we're doing that so that this integral turns into the square root of u times x, and then we're going to solve for, if we take the derivative here, we can solve for dx. Right, we get dx equals du over 2x. So here we, instead of writing this dx, we write du over 2x, and this x cancels this x. So we're left with 1/2 times square root of u, which is u to the 1/2. If you integrate this, you get 1/2 times u to the 3/2 divided by 3/2, or times 2/3. Right, so these are going to cancel, And so you're left with u to the 3/2 over 3. Don't forget plus c. And then we remember that u was x squared plus 1. So we have x squared plus 1 to the 3/2 over 3 plus c. And this is equal to square root of x squared plus 1 times y. If we're trying to solve for y, then we can divide both sides by x squared plus 1. So you end up with x squared plus 1 to the 3/2 over square root of x, and let's go and write the x squared of x squared as x squared plus 1 to the 1/2. And then there's that 3 factor here, so I'm just going to write that 3 factor here. These have the same base, so they can be combined. The way we do that is it's just like if you had 5 to the 3rd over 5 to the 2nd, you would subtract the exponents, right? It's the same idea there. So really we're going to get y equals, we're going to subtract these exponents. 3/2 minus 1/2 is 2/2 or 1. So we get x squared plus 1 over 3. And there's a plus c here as well. Something doesn't seem quite right. 3/2 minus 1/2. Okay, yeah, I see what I did. So there's a plus c here, right? There's this plus c there. So like when I divide by this guy, the plus c also has to be divided by that guy. And so this is actually plus c over square root of x squared plus 1. And then they give us a initial condition, which is y is 1 when x is 0. So we could plug in 1 here, plug in 0, you get 1/3 plus c. So c should be equal to 2/3. Therefore, our final equation here might be, this is 2/3, so that'd be 2 over 3 square root of x squared plus 1. And you might see different versions of this. If I wanted to find a common denominator, I could multiply both of these. I don't need to multiply this one. I can multiply this one by square root of x squared plus 1. And that would give me square root of x squared plus 1 times x squared plus 1 plus 2 all over 3 square roots of x squared plus 1. And then I could mess around with this too, and this could become to the 1/2 because it's square root, and this is to the 1. They have the same base, so it could be x squared plus 1 to the 3/2 plus 2 over 3 square root of x squared plus 1. I think this is the answer that the mark scheme gives, so I just want to show you how you could get to that. And I might avoid some complication if I just didn't simplify over here in the beginning. But like there's nothing wrong with this answer, just like that. There's, it's almost easier that way. So that works also. Also, I was looking at the mark scheme and noticed that for the show here, they did a little bit more work than I did, right? Like I found the integrating factor using, that way, but they actually want us to show in the work here that this works out to the way we want it to work out. So let me take that, right? So just remember how we found this integrating factor. And what we want to check is we actually want to do this math that I didn't do here by actually taking the derivative of this and showing that it's going to work out to be what we started with up here, right? So if I take the derivative of this, again, it's going to be derivative of the first one, which is derivative of this. Again, this is same as to the 1/2 power. So it's going to be 1/2 times x squared plus 1 to the negative 1/2 times 2x, and that'll be times y. And then we're going to add derivative of the first one is dy dx, or sorry, derivative of y is dy dx times square root of x squared plus 1. And that's going to equal square root of x squared plus 1 times x. Right, and so then I just need to rework this thing. If I look at this piece over here, I can rewrite this as 2x over 2 times the square root of x squared plus 1. And then this one is square root of x squared plus 1 times dy dx equals square root of x squared plus 1 times x. So what should happen is I should be able to find a way to find a square root of x squared plus 1 in all of these that I can then factor out and end up back where I started with a form like this. And I'd lost my y right here. There should be a y there. So in order to do that, we want to, these 2's can cancel, right? We could, okay, so we could factor out a square root of x squared plus 1, right? So we're going to write square root of x squared plus 1, and then think about, and we're just doing this left-hand side, what would be left in here if I factor a square root of x plus 1? Right, factoring out, it's like dividing by, right? It's like multiplying by 1 over square root of x squared plus 1. If I do that here, my square roots cancel, and I'm left with 1, I'm left with x over x squared plus 1 times y, and then this one just comes out, and I am dy dx. Right, and so then you can see there's a common factor, square root of x squared plus 1, which is what we multiplied out throughout the whole thing anyway. And so that is, we have shown that that is our integrating factor, right? Because it's just square root of x squared plus 1 times the left side and the right side. So a little bit extra work that we might have done there. All right, so I'll move on to number 3 here and do a different video for it.